hopefully we can do everything today, right? So integration methods continued. We want to talk about our integration method. I think it's like 8, 9, 10, 11. There's like 4 more to do. Every semester I do it, it's a different number of methods because I just improvise when I'm teaching it. So we want to do inverse trigs. And of course, when I do this, I only will do inverse sine or inverse tangent. There's no bother with inverse cosine because it's just the negative of inverse sine. And then I don't do the other trigs, the other inverses either, right? Inverse secant, inverse, etc., right? And then I want to talk about, so there's, I think it's 3 to 4 methods here. And then I want to talk about U sub with definite integrals, right, where I'm getting the area. So I just have to do those 2 things today. Those are the new things. I'm going to be looking at Chalmers right now. This is my Chalmers outline for calculus. Again, all of you students going on to higher level classes want to look into these. So the calculus Chalmers outline for calculus, Lucy, is for Calc 1 and Calc 2. And then there's one for multivariable, there's one for diff EQs, there's one for linear algebra, there's 2 for linear algebra, just the outline and then the advanced. For physics, they have them for all science and engineering classes and math classes. And they're worth it. It's every single possible problem you could ever have. And I'll say it probably saved me in undergrad and grad school. So this is just, I'm just going to pick a couple problems from Chalmers of methods we've already done. So this is number 9. Right, and I'm asking you again to do 1 to 72. 9c, Chalmers 9c, the integral of 8x squared over x cubed plus 2 quantity cubed dx. So going down the list, you certainly could talk yourself through the list, but if you see it clear inside, that's for sure probably the way to go. And again, there's nothing wrong with trying a method and it failing. There's nothing wrong with that. It's a good thing to have happen to you. So u is going to be x cubed plus 2, clear inside, right? And what's du?
Du will be 3x dx.
Nice. So 3x squared, right?
Yes.
Yes. So meaning I'm going to want to take this 8 out of the integral. Remember, a coefficient moves in or out of a sum of a derivative of an integral, right? Because both of those are right limits, things like that. So I have my original problem still, and I need to multiply by 3. So I'm going to multiply by 3, and then to cancel that, I need to divide by 3, right? So now I see I have 8/3 of the integral of 1 over u cubed du. How we doing? Okay. So I have 8/3 of u to the minus 3, and I'm integrating, right? So I'm going to add 1 to my power and divide by the new power and add a constant c. How we doing?
Yep.
Nice. So then I just clean this up a little bit. It looks like I'm going to get negative 4/3 u to the minus 2 plus c. So I like c minus 4 over 3 u squared. And of course u, we know what u is. It's x cubed plus 2. And done. This is number 23. Everyone okay? Marcus okay?
Yes, can you zoom out for me, please?
Yep.
So that, thank you.
Yep, there's the whole thing. Afsu, question?
Yeah, Professor, this wasn't a new method, right? It was just the
No, I'm just doing a couple of just to kind of warm up a little bit. Just doing a couple of problems up to where we are, and I'm in the Shams outline, and what we're doing today in Shams starts at number 48. So I'm doing random problems up to 48 right now. Yep. Okay, this is number 23. I tend to give hints. Like on this one, on the test, I would say something like divide and conquer, right? So 23 is the integral of x plus 2, that quantity, over the quantity x plus 1 dx. Now, you could see, this is Shams, number 23. So I will say something. You leaving? Hold on a second, everybody. I'll be right back. 1 second. See if you can start this. So you can start with long division or divide and conquer. Let me hug. Gummy bears are open on the front seat, so if it smells sweet in there, why? I cut them open, and it's got a resealable, but I didn't want you to try and open it in the car while you're driving. Your bagel's out here.
What?
Your bagel's out here. Okay. And the coffee cup is clean. There's 2 bagels. One's for you. Unless you want to bring one.
No, that's fine.
Okay.
Thanks.
Here you go. Okay, sorry about that. So long division is a good way to go here. Divide and conquer also works. They give you the same result. I'm going to do divide and conquer, okay? Did anybody get the long division already? No one did it? What the hell?
I was writing out the problem.
What? I'm sorry, hold on, please. What are you saying? Come try this.
Where's the gummy bears?
In the front seat of the car. I thought you said something else. I can't hear a thing. I can't. My ears are both like clogged. Okay, I'm sorry. Gummy bears on the front seat of the car. Okay. Passenger side. Okay, sorry about that. So if anyone did the long division, and I'm hoping you did, you get the integral of 1 plus 1 over x plus 1 dx, right? So that's going to turn, what? I'm going to divide and conquer, just so you see it, okay? So this is x plus 1 all over the quantity of x plus 1. So you can see I can now take a multi-term numerator and split it into two or more fractions, right? This one could be split into 3 fractions, but it's splitting it into 2, which makes more sense. I get x plus 1 over x plus 1 dx plus the 1 over x plus 1 dx, right? And so, and you see the very next line, the x plus 1 over itself is 1, right? So that's where I'm at. Oops. And I really want to just think of those as 2 integrals, right? So, and I need the dx, right? Remember, dx is part of the operator. So as I split it into 2 integrals, I get the integral of something dx, and then the integral of something else dx, right? So the first integral is pretty damn easy. It's just x, right? And the second integral, you should see is 1 over x, just shifted, right? You could do the whole u sub if you want, but it's just the ln of the absolute value of x plus 1 all plus c. And again, the Shawms doesn't put the absolute value in. I am going to ask you to put that absolute value in when necessary, right? Yes, Asu?
Is that like a couple steps up?
Yep. So
there's a section. You said divide and conquer, and I had previously thought of that as like if we had x squared plus like 6x plus 2
Yep.
all over like, I don't know, x cubed.
Yep.
Then I would put the x
all
cubed
3
under each. That's
exactly.
the same thing
Exactly.
we did here, except we chose to keep it like convenient.
Yeah, exactly.
Okay.
Yeah. You got to be creative, and you know, I was always worried. For me, as a student, when I was learning this, I was worried I wouldn't know what to do. So I did every problem in the book, and then I realized I still would be given something I didn't do already, right?
Yeah.
And but I had been practicing enough that I could kind of improvise when I got to something that I wasn't sure about. And so it's about practice, right?
Mm.
Nice.
Okay.
Let's do another one. Yes. This is 29. We've got the integral of e to the 3 cos of 2x times sine of 2x dx. So this is one of those ones, it seems like you see both two of my methods at the same time. You see, I have a function and I see its derivative, but I also have a clear inside. In fact, the inside has an inside, right? So just to make the u sub of u could be the way to go, but and you could do that. So then you do a sub with u, and then you do another sub, and I would use like w, a different letter. But on this one, I could choose u as my entire 3 cos 2x. Now there is an inside there, but no big deal because we're going to do chain rule, right? So to get du, I'm doing what? 3 goes for the ride, right? Derivative of cosine is negative sine, right? And then the derivative of the inside is 2, so I end up with a 6 here, and dx. So you can see I almost completely have du, right? All I need to do is multiply by a negative 6 and divide by a negative 6. And so now you can see I have negative 1 over 6 times the integral of e to the u du. Nice, that's easy. I get c minus 1/6 e to the u. And now I can put my value of u back in. c minus 1/6 of e to the 3 cos of 2x. This is 38. And I'm doing the integral.
But first,
Yes.
these questions, they come from like the white answer for this from Stewart, like the name of the book.
No, these are from Schaum's outline.
Where I find Sean's outline?
What?
Where I found Sean's like this?
Oh,
this like
bookstore?
Oh,
A nerd bookstore. You can find them online. You can buy them brand new on Amazon for about $15.
okay.
You can
Pedro,
find.
he shared this with us.
Hmm?
These like problems he shared with us to practice. It's
Yeah,
like,
yeah. I put them in that announcement that I sent out Wednesday.
Okay.
So I just did a PDF. You know, I took a cam scanner, took photos of my book, and
Oh,
Yeah.
that PDF that we downloaded on Wednesday.
yes,
Oh, I remember that. Yeah.
nice. So 38 sine x plus cos x, that quantity all over cos x. You can see it's hinting at a divide and conquer, right? Because you clearly see when you get cos over cos, you get 1. So it should be really obvious that we have now the integral of tan of x plus the integral of 1 dx, right? So sine over cos is tangent, cos over cos is 1, right? Divide and conquer in my head. Be careful about doing things in your head, right? But the tangent, the integral of tangent is just like the integral, like when we did the derivative of tangent, right? We want to really be thinking of sine x over cos x. So when I did that divide and conquer, I probably didn't need to change it into tangent, right? Now I did one integral here, right? The integral of 1 is x. I don't need to do the plus c until I'm done with all the integrals. So there might have been a plus c here. But then I'm going to get another plus c from the other integral, and then I'm going to put those two constants together and get a different c. But it doesn't matter. We don't know what it is, right? So so what do I get here now? I get u is cos of x. Clear downstairs, right? Du is, the derivative of cos is what? Negative sine. So I need the negative, and I cancel the negative. So it looks like I have x minus the integral of 1 over u du. And that's, of course, ln of the absolute value of u plus c. But u is cos, right? So cos, absolute value of cos. Do I need the absolute value for cosine function?
Yeah.
Yep, goes underground. Cos goes underground onto the x-axis, right? I can get a little creative here and put that negative inside. And a negative exponent means reciprocal. And 1 over cos is secant. It's debatable on which of these boxes is better, but I think you can tell. It's good to go through and see if you can simplify things at all, but the first box has one less stroke in it. So I'd argue that the first box there is a better answer, right? In the first answer, I have a negative between my two. And in the second one, I have a positive between the two. So that extra stroke seems a little bit unnecessary. But those answers are pretty. We want pretty if we can.
Professor,
Yes.
could you go back to the last problem?
The last problem.
Yeah.
Yes, of course, Jim. Talk to me.
Oh, and I just want to check if I was good.
I'm sorry?
I just want to check if I got the answer.
Oh, gotcha. Okay.
Oh, I'm done.
Which one, Chimok? I'm not. You're breaking up a little bit.
Oh, no, I mean, I'm done.
Oh, okay. Nice. Gotcha. Thank you. Nice. The last method we did yesterday, Wednesday, there's a couple of examples in that final exam review. Make sure you do those. Okay.
Yeah, I got a question, Professor.
Yes.
For tangent dx, if I write the derivative 6 square x, will that be a problem?
Yes, because you're doing the integral. You're not doing the derivative. And it's a problem with a lot of students make this problem. Because we're almost doing derivatives and integrals at the same time here. A lot of times students will do a derivative when they need to do an integral. They never do an integral when they needed to do a derivative because we've been doing so many derivatives all semester. Sometimes you forget you're undoing the derivative when you're doing an integral.
Okay, thank you.
Yes, soon.
To clarify, I always tell myself for these that we're only doing derivatives when it's like diffuse, and we're only doing antiderivatives when there's like the little s sign
That's
of
right.
the integral.
That's right.
Okay.
Yep. And the s is an integral. It is a sum, right? Remember, we're summing up areas of rectangles, right? An infinite number of them. So when I do a definite integral, I get an answer. I get a number, an area. When I'm doing an indefinite integral, I'm getting a function that will give me an area, right? Just like when I was doing derivatives, I could get a slope, or I can get a function that would give me a slope, right? So there's the difference. If I'm actually calculating a derivative to get a slope, I'm getting a number. If I'm calculating getting a derivative to get a function, then I'm getting the machine that will give me a number at any point, right? So same thing with integrals. If I'm doing a definite integral and I see the bounds on the integration, I know I'm getting an area. Otherwise, I'm getting a function that would give me an area, right? So, all right. So let's do I'm worried about doing this method first because it will definitely give us a headache, but I think it's the right thing to do. So I want to do this last integration method, which is inverse trigs. And I think I have 4 levels of them. We'll see, right? So first of all, I could see something like just the plain old integral of my inverse trig or inverse sine, right? So this is an arctan of x plus c, right? So this is my last method, right? Inverse trigs. I could see something like just the direct version of arcsine. So I just want to make sure I recognize those, right? And remember, on your formula sheet, you only have to have your set of derivatives or your set of integrals, and then you can see either way, right? I personally would rather have my set of integrals on the page. I think it saves a little bit of space. And then I, working backward, I can see the integration, right? Of course, if you have room, put them both on if you want, right? When it gets a little tricky is if I have something. So there's my first level. So there's number 8, right? Number 9 is I'm going to have something that looks really close to what I want. Like, for example, I could have the integral of 1 over 4 plus x squared dx. So just going to take a little bit of algebra, really arithmetic, to turn this back into an arctan. It looks so close to arctan, right? except for what number?
I guess the 4.
The 4, exactly. So I want to get rid of the 4. And the only way I can get rid of a 4 is by multiplying by 1, right? Or you could think of it as factoring. So I'm going to...
Also,
yeah.
Don't we run into a lot of functions that look like this 1 over number plus polynomial kind of deal, where it's like...
Yes,
so what you're hinting at is there's a lot of arc tangent, or there's a lot of arc trigs in integration.
I mean, as much as anything else, I don't think it's more than, because most of the time when we had something like this downstairs, we picked the downstairs to be U. But in this particular case, what happens if downstairs is U? What's du? In this particular problem here, in level 9, if I let U be the downstairs, right, du is 2x dx. I can get the 2, I can't get the x, right? I can't
x
no,
high the top.
no. So it doesn't work. So what I'm saying is it's most likely an inverse trig right now. Okay, so that's what you're looking for. You see it clear downstairs, you try it, but it doesn't work, right? So it looks like I have to factor out a 4. So I get now 1 over 1 plus x squared over 4 dx, right? And you could clearly see if I distribute that back in, I get the original problem. It's looking more like arctan now. Go ahead, Afsun.
So even if we multiplied like 2x over 2x, we couldn't do that.
Well, that's a nice idea, but look at what would I have to do? I'd say, and let me do it in green here. I'd say, okay, 2x, and then I'd have to cancel it. But where did I put that other x?
I'm sorry?
Where you see where I put the other x?
Yeah.
I can't do that because the integral is dependent upon x, right? This guy's telling me you've got to do something to your x's. Okay, so then maybe we do this. Hold on, Pedro. Maybe we do this, right? So maybe we do this. We put the 2x inside, and then we cancel the other x inside. Okay, this is wrong too, but it's okay to say it. Look at it. So now I have 1/2 of the integral of 1 over x times 1 over u du. And then you say, okay, well, let's solve for x here, right? So if u equals 4 plus x squared, then u minus 4 equals x squared, and x equals plus or minus the square root of u minus 4. Okay, let me put that in. So I have 1 over u square roots of u minus 4 du, and I don't know if you can notice, but this is turning into something far worse than I had originally. And this is kind of your hint of don't keep going.
Yeah.
If it gets nasty, don't keep going. Right? Okay. If we start at level 8 in our list, it should get simpler. Right? It should end up with something we can integrate very easily, very quickly. It shouldn't get worse. Okay?
Okay.
Yeah.
Thank you.
Good question. Yeah, so all of this is not gonna happen. You'll know it pretty quick that it's getting worse. You'll be like, oh my God, what the hell? Okay, so it looks like I really want what? 1 over quantity 1 plus u squared. And I can see I have that, right? I've got 1 over 1 plus x over 2 quantity squared dx. So there, now I see, and this is the weird thing, is now it turns into a u sub inside, right? Do you see the clear inside? I now have u as x over 2, and du is 1 over 2 dx. Okay, I have a 1 over 2 here. I have a 1/2 times a 1/2. That's my 1/4. So I'm going to take that 1/2 out of my outside factor and put it inside. And now I can finally make my u sub, right? So I have 1/2 of the integral of 1 over 1 plus u squared du. And I finally see I have 1/2 of the arctan of u plus c. But u was x over 2. So 1/2 of the arctan of x over 2 all plus c. There it is.
That wasn't proper English.
What?
You was?
You was?
You were?
Yeah, I get it.
Brother, can you scroll to the, just like a couple of lines above it?
Yep.
Okay.
So integration method 9 is I recognize something that kind of looks like arctan, but I have to manipulate it algebraically, arithmetically, right? I have to do something with it to make it into that 1 over 1 plus u squared.
Question. If we took out 1/4, so that we could get the 1 over x squared on the bottom,
Yeah.
how come we didn't do like 1/4 on the top? Because I thought we were dividing the whole thing by 4.
Yeah, I am doing that. But it's the same as factoring. So either method will work and will get you the same result.
So
you're saying I like what you're saying. So you're saying, well, why don't I just divide everything top and bottom by 4, right? And so I divide this by 4, I divide this by 4, I divide this by 4. And you see, this turns into a 1, and the 1/4 goes outside. So it turns into exactly what I did by factoring.
okay.
So either way is fine with me. You don't have to do your arithmetic the way I do my arithmetic, right? And we're all in calculus, so we know how difficult algebra can get. And so we do it any way you want. Just can't break rules, right?
Thank you.
Yeah. Well, here comes the beast level, okay? This is beast level. There's probably a level in between that I'm forgetting about, but I always give the beast level problem on this test, okay? So here it is, and I'll grab one from Shaw's here. Well, let me do one level before beast level, okay? So this is Shaw's number 65. I've got the integral of 1 over x squared plus 10x plus 30 dx. And so you can clearly see I would try a u sub downstairs first, right? I would try a u sub downstairs first, but it will fail right away because I can't get an x upstairs, right? You see I need a 2x plus something, right? 2x plus 10, right? I would need a 2x plus 10 upstairs to have my du, but I can't get the x. I can only multiply by 1 using coefficients or add 0 using coefficients, right? And you'll see me do that, add 0 on the next problem. So this one, I'm thinking has to be arctan only because there's nothing else in my list. And yes, Robert is evil, but he's not going to give me a problem that can't be done. Well, talk about chapter 4 test. So I'm thinking it's arctan, which means I have to get what? I'm looking for the integral of 1 over 1 plus u squared du. And so guess what? I have to complete the square. I have to complete the square to get this to work. So we're going to complete the square. Hopefully you had a pre-cal teacher that demanded that you complete the square because they knew that you needed it for calculus. And like when we were doing transformations of functions, remember that in pre-cal? Like take a function and shift it left or shift it right, shift it up or down. We did that with quadratics by completing the square, by finding the vertex form of it. So that's what we're going to do here. My method of completing the square is my method. So if you're having trouble with completing a square, go find someone's method that you like on NerdTube, you know. And but what I do is I like to group my x squared term and my x term in the paren and leave the constant out. I want to make sure my leading coefficient of x squared is positive 1. If it's not, I have to factor it out, and we'll do one like that today. So now I've found the value of k. I say k is the coefficient of x. I could say it was ax squared plus bx plus c, but when I factor out a leading coefficient, it's no longer that b from the quadratic, right? So I say it's k, and then I go half of k, which is 5, and then I go half of k quantity squared, which is 25. And I'm going to add 25 inside and subtract it outside. So now I have, in parentheses, a square. We did it on purpose. We have a square. So I have now 5 plus the square of x plus 5 quantity squared, right? 30 minus 25 is the 5, right? And then the x squared plus 10x plus 25 is x plus half of k quantity squared. Every time. Right? Every single time. So I'm looking a little bit better for my integral now, right? Yes? You with me? It's looking more and more like 1 over quantity 1 plus u squared. But what don't I like? I don't like the 5, right? So I'm going to do that same thing before. Divide everything by 5 is fine. So let me do that way this time. Divide everything by 5. And then I want that 1/5 that survives inside of my integral to go into the square. So I'm doing now 1/5 times the integral of 1 over 1 plus x plus 5 over rad 5 quantity squared dx. It's hard to believe that this is not yet beast level. Right? It's pretty tough, but you just got to practice. Do as many problems as you can until you get it. It's just like being a musician. You've got to practice. It might take you 2 years to learn a song, and then another 10 to get the feel, right? To get the real soul of it, right? And we're trying to do that inside of 40 hours, right? Our full-time job right now is school. So we have some other classes, but so we should be able to take at least 10 hours and work on this stuff this week, right? Now I'm ready for a u sub. So I'm going to let u be this inside x plus 5 over rad 5. And of course du is the slope, which is 1 over rad 5 dx. Sorry, yep. I have, if you can see, I have a 1 over rad 5 here. 1 over 5 is 1 over rad 5 times 1 over rad 5, right? So I'm going to steal that 1 over rad 5 from here. And now I can make my u sub. So I have 1 over rad 5 times the integral of 1 over 1 plus u squared du. Beautiful. Well, that's arctan. Ha! I got it. Arctan. So I have 1 over rad 5 times the arctan of x plus 5 over rad 5 all plus c. Beast. That's half beast. That's a beast without claws, and now the one with claws is coming.
You zoom out a little bit, please.
I can zoom out as much as you want me to. I got mad zoom skills. And that's not just because I'm teaching through Zoom.
2 years of Zoom?
Yeah. Off Zoom, what's up?
I was good until like the step right under the purple like U and U.
Yep.
How did we make the like? Actually, move on.
Yeah. So the key here was I needed a 1 over rad 5, right? And so I noticed that 1 over rad 5 times 1 over rad 5 is 1 over 5. I don't have to do that. I can just leave my 1/5 outside, multiply by 1 over rad 5, and divide by 1 over rad 5. So I can do my same cancel thing. If you don't like what I did here, do the same cancel thing when I had to multiply by 2 and divide by 2, right? Here you would have had to divide by rad 5 inside and multiply by rad 5 outside, and that's fine. You could do that.
Okay.
Nice. Let's go to beast mode. Where is my paper? I want to get my final exam review. Okay, give me a second. Oh, do I need to do that? I don't know if I need to do that. All right, this is number 68. This is the last level. So the first one we saw was, all right, recognize the antiderivative. Recognize that you have the derivative of arctan or arcsine, right? That was level 8. Level 9, notice that the U sub downstairs doesn't work, so it's probably an inverse trig, right? And in that case, you're going to just manipulate algebraically, arithmetically, to get it into a 1 over 1 plus u squared. What happens next is I try all my methods. It's obviously a u sub downstairs, and it fails, so I'm thinking it's an inverse trig, so I'm going to complete the square. There's 8, 9, 10, right? Here comes 11, is my u sub downstairs works, but there's a leftover piece, okay? So then we're going to divide and conquer. So here it is.
Yeah, excuse me, Professor. Can you do what, like, arcsine, please?
Yes, I will. I promise. And that'll be the last problem we do for this topic today when I get to the arcsine problem. So this is from Shams. This is number 68. And I'm doing the integral of x over, and I'm changing it just a little bit, x squared minus 4x plus 8. I guess I don't have to change it. I'll keep it exactly as it's written. So it's x quantity, x plus 1 in the numerator, x squared minus 4x, that's a 4, believe it or not, plus 8. So it's pretty clear, if I'm going through my list from 1 to 11, I get to a u sub downstairs first, right? Before anything else makes sense. So I get to a u sub downstairs, and I'll do that. So I got a u is x squared minus 4x plus 8. And that means du is 2x minus 4. All right, cool. I can get 2x out of this, right? So, and I'm kind of working with inverse operations, PEMDAS. Please excuse my drunken insanity, right? I'm kind of working with that. I want to multiply and divide before I add and subtract, right? So I'm going to multiply this guy by 2, right? And divide by 2. Yes, you with me? Oh, there's a dx here, sorry. Nice, so I now have 1/2 of the integral of 2x plus 2, right, over x squared minus 4x plus 8 dx. Okay, but there's a problem. I need 2x minus 4, right? So in order to make that happen, I'm going to add 0. I'm going to subtract 6 and add 6. So what do I get now? I get 1/2 of the integral of 2x minus 4 plus 6 all over x squared minus 4x plus 8 dx. Everybody with me? How are we doing? Do you enjoy being this intelligent? That you understand this stuff? That you're close to being able to take classes that could possibly explain the existence of us, of the earth? Pedro's saying no.
Seems like a paradox to ask this question after what you just said, but we just added 0, right?
Yeah.
Okay.
We do nothing all the time. I love to do nothing. Sometimes I'll accidentally sit down on the sofa and forget the remote control, and I just decide at that moment I'll do nothing. So doing nothing is pretty important in mathematics. So now I'm going to divide it.
Excuse me, but so you add 0 to find 2x minus 4, right?
Yep. Mm-hmm. So now I'm ready to divide and conquer. Should be pretty obvious. I have the 1/2 of the integral of 2x minus 4 all over x squared minus 4x plus 8 dx plus 1/2 of the integral of 6 over x squared minus 4x plus 8 dx. And so you can see on the first part, I'm going to get an ln, right? I'm going to get a 1 over u du, right? Integral of 1 over u du. And on the second one, I got to complete the square. So on the first one, I already know I have 1/2 of the ln of the absolute value of x squared minus 4x plus 8. And then over here, I want to turn it into, so this is 1/2 of 6, it's 3, right? I want to complete the square like I did in that previous level to find an arctan there. Okay, so Horatia, go. How are we doing?
Just have a question on, there we go. It's right on top of the 3 times the integral of 1 over x squared minus 4. So how did we go from 1/2 and 6 to
Half of
3?
6. Half of 6.
Yeah.
Yeah, half of 6 is 3.
We just took 6. Oh yeah, coefficient. Yeah, cool.
Yep.
Yeah, my question is, how did you know the first one is ln?
I did the 1 over u stuff in my head, right? So I'll go over here. I'll say this is 1/2 of the integral of 1 over u du. So ln, right?
Okay.
Now, I tend to do these as 2 different integrals and then put them together at the end. So I don't have to keep writing this long thing out over and over, right? I'll call this one hashtag and this one star, and work on hashtag, work on star, and at the end put them together. Go ahead, Jesse.
Did you keep the 1/2 from the part right below that?
Yes, when I divide it and conquer, I keep the 1/2 on both integrals, yeah.
Okay, I think you just didn't write out on.
No, I did half of 6. Oh, I did the square root. Remember, 1/2 of the ln of an argument is the square root of the argument. It's the ln of the square root, right? From pre-cal.
Okay.
Yeah.
That's where it came from.
Yep. Afsun?
But we're not, like, done, though, are we?
No. I got to complete the square.
Okay,
I got more work. I still have an integral in there, right? I want to get the antiderivative, so there should be no integral left, right? So I'm going to divide by 4, right? So it looks like I have now the ln of the square root. Where do my absolute value go? X squared minus 4x plus 8 is above the x-axis, so it's always positive. Plus 3/4 of the integral of 1 over 1 plus x minus 2 over 2 squared dx. I can see I need a du of 1/2 dx, but I have a half here, right? I have a half here. So I have now plus 3/2, the integral of 1/2 over 1 plus x minus 2 all over 2 quantity squared dx. And I'm ready to make my u sub finally. I feel like I might be going too fast. Everybody's here. All 16 students, all 16 survivors. I'm the sole survivor.
Yep.
You're doing really well. The class average is 82. The class average in my face-to-face class is 70. So I'm happy with the work you're doing. So this is arctan. So I have the ln of the square root of x squared minus 4x plus 8 plus 3/2 of the arctan of u, which is x minus 2 all over 2, all plus c. And there it is, beast level. We'll do one more that's like angry beast level.
Yeah, before you go doing good business, level just
Markins, you losing it? You losing it?
No, I'm good, but I was just paying attention to him.
Where did you get the 1/2 in the numerator?
I borrowed it from the 3/4, right? 3/4 is 3/2 times 1/2.
Okay.
Yeah.
I think you need to zoom more, Professor.
Sure. There's the whole thing.
Professor, I had a question similar to
Go ahead. Talk to me.
that. So I know how we did the 1/2, but why?
Because I needed it for my u, right? Remember, right here, I didn't write it, but u is x minus 2 all over 2, so du is 1/2 dx. Right? I need that slope there. That's a mx plus b there. And the slope is 1/2.
Okay. Okay, yeah.
Let me get my final exam review. I'll be right back 1 second. It's in the other room. Okay, here we go. Last problem on this topic, and then I've got to do that final u sub with definite integrals. You'll see it's very easy. That last piece is very easy. I know you probably have a raging headache right now, but it's Friday. We can do it. We can handle it. So this is an arc sine with a leading coefficient. This is angry beast mode. Okay, I haven't put one of these on the test. I did once, and I had a couple students crying, so I stopped putting Angry Beast Mode problems on. So
Maybe we could put Angry Beast Mode problems for the extra credit.
Yeah, well, because if I'm going to put a Beast Mode one on, right, like the one we just did, so I to make you do one more with just one extra tricky step seems a little silly. But maybe I'll put an extra credit on. I mean, I'm already right. I give you 7 problems at 15 points each, so it's the test is worth 105, right? You could score 105. So there's kind of a extra points built into it already, and then I don't know. You know, if I did put some extra, what I did on my what I did on your last test is I said, well, if you can tell me how to do this, I'll replace your lowest points problem with 15, a full 15, and that worked out pretty well for a bunch of you.
I liked that question.
Yeah, you did. Nice. So here it is. I have the integral of 1 over the square root of 8 plus 2x minus x squared, all with respect to x. Right? That's that dx. It means I'm integrating with respect to x. So you can see here, I clearly have an inside. I clearly have a downstairs. Both of those fail. So, right? So since I'm, at that level, the next thing I'm thinking of is inverse trace. And I recognize, because of the square root, it's probably an arc sine. Right? So I'm looking for that. Right? So if I take the u sub inside, I get a negative 2x. Can't make that happen for my derivative, right? If I take the whole square root, it gets really nasty when I do find du, right? So if I take the whole downstairs, it gets really, really messy. So I'm really thinking it's an arc sine. And what do I have to do now? Complete the square, right? So I'm going to complete the square with negative x squared plus 2x plus 8. So I want to group together my x squared term and my x term. But I want to factor out, I want to make sure my x squared term has a leading coefficient of positive 1. So I have to factor out a negative. All right, now I see k. I call it k so I could use the joke. If you see k, you're fine. If not, if you see Kate. I'll get you fired for that. So I see k is negative 2. Half of that is negative 1. And if I square that, I get positive 1. I'm going to add 1 on the inside, but notice that adding 1 on the inside is actually subtracting 1. So I have to make sure I add 1 on the outside.
So, it's the one where it's negative leading coefficient.
Yeah, exactly. So now I have 9 minus x minus 1 quantity squared, x plus half of k quantity squared every time. Every time I complete the square, I get x plus half of k quantity squared. And you see, I'm looking a little bit more like what I want for my arc sine, right? But I don't like the 9, so I'm going to have to deal with the 9, right? You with me? So this guy is star, just so I can say down here, star is now equal to 1 over the square root of 9 minus x minus 1 quantity squared, all with respect to x. How are we doing? We okay? Nice. 1 thumb up.
Yeah, my video's frozen again, but I can see them.
Yeah, mine is acting a little sluggish today too. Well, I mean, we made it all the way to the end of the semester. Only 4 of you have cameras on anymore. Damn it. But whatever. I don't want to see y'all anyway. Okay, so I'm going to divide everything by 3, right? You agree? Dividing everything by 3, because the 9 is inside of the square root. So inside the square root, I'm dividing by 9. Outside the square root, I'm dividing by 3, right? Square root of 9 is 3. So I have 1/3 times the integral of 1 over the square root of 1 minus x minus 1 over 3 quantity squared dx. And can we do this u sub in our head anymore? Anyone see what du is going to be?
You equal x over 3 dx?
Yeah, and 1 over 3, right? Just the slope. 1 over 3 dx, right? Anybody not see that? So I know that u is going to be
This is x over, yeah.
Yeah, I'm going to use my inside. So du is just my mx plus b is just the slope m. So, and I have a 1/3 dx. So I've got everything I need here. I don't need to do anything else.
So, if I say x over 3 is incorrect, Professor?
Correct, because what's the slope of x over 3? One over 3.
1/3.
1/3, yeah.
Sorry, I have to always replay the question in my head to actually get the answer.
Not a problem. So it looks like I finally got it. I got arc sine of x minus 1 over 3 plus c. Yes.
Wait, where'd our 1/3 go?
1/3 dx is du. Right here.
Oh, okay, that's crazy.
Yeah.
Okay. That's convenient.
Yeah, I mean, but you could do this, right? You could divide by 3 inside and multiply by 3 outside, but then you get a 3 over 3 outside, which is 1. You could do that. It doesn't matter, you know. Don't doubt your arithmetic skills, right? Don't doubt your algebra skills. Do what you need to do, which is nothing. Multiply by 1, add 0. So we've been doing it all semester. We've been doing nothing all semester.
You said that at the beginning of the semester, yeah.
We're
going to do
a whole lot of nothing.
Adding 1.
Yeah. Multiplying by 1,
1.
adding 0, yeah.
Can you scroll down a little bit, please?
Hell yeah. So there's a bunch like this in Shawms, if you want to do another one, but I'm not going to go Angry Beast mode on your test. Assume, what's up?
I don't know why, like, at the star level, you like divide by 3 and
because I divided by 9 downstairs inside of the square root.
Yeah.
Yeah. So outside of the square root, I'm dividing by 3.
Okay.
A 9 inside the square root is a 3 outside the square root.
You could say you have a 1/3 on the outside that distributes to the inside. It's just an extra step, or
of course,
doing the algebra differently.
Of course.
Same.
Like I said, I don't care how you do your algebra. Just don't fake it. I mean, don't just put things in to make what you want happen without it actually being true. I'll send another question, or
No.
Yeah, no problem. No problem.
I have about 10 to 15 sheets of notes from that are saved now.
What? Oh, what? Well, yeah.
Started at 1, and we're at like 9.
Yeah, that's a surprise to you.
No.
Okay. Okay. Good. I remember.
Some of them are much taller than the others.
I remember. Probably it was Calc 1. No, it's Calc 2. I had like a 5 subject notebook, and I went through the whole thing with just notes. And so
just
I went
subject.
Went on to another. One subject is 5 subjects. Yeah. All right.
Yeah, I have one of those, and I think I got past the first orange divider. I'm like halfway in the second.
Yes, but you don't take as many notes as I do.
I had one 2 years ago that I chewed through half a notebook, but we'll see over the summer.
Yeah, so summer is kind of officially stated. I know I said it last time, but vaccine or not, you can be on campus.
Right.
And I'm talking to everybody. So,
yep.
Whatever. I don't want to do anything else today, so I'll do this last piece on Monday, unless I'm not here. It could likely be that I might not be in school at all on Monday and Wednesday. I don't know. We have so much to figure out. But I'll make sure you're all taken care of. If I'm not here. Okay?
Yeah.
So get some practice in. Start working on those problems 1 to 72. If you remember, I had problems in the textbook. Those problems with the definite integral, that piece, you certainly could do it. And so what you have to do is when you make a u sub for an integral, you have to return to x's. So at the end, notice I'm returned to x's, right? At the end here, I have to get back to an x function of x. And then I evaluate to get my area. And what I will show you next week is I can stay in as a function of u and evaluate. So it saves a couple of steps. This u sub for definite integrals saves a couple of steps, but not absolutely necessary. But I'll do that Monday. Austin, what's up?
We completed the square in the first 2 steps of this problem, but if we didn't have it as something as convenient, so if 2x wasn't there, how would we get to make it?
Yeah. So I'm a little worried about hypotheticals, because if we're going to do a hypothetical, right, let's make me a millionaire, and then class is canceled. Okay. So if I didn't have the 2x, I can still complete the square here, right? This is what? Square root of 8. I'm sorry. I lost my concentration here. I'm sorry. I can still complete. This is really easy to complete the square. I just can't quite think of it right now.
Negative, and then parentheses x, plus 8 on the outside.
Oh no, yeah. You're right. It's 8 minus x minus 0 quantity squared. It's because that's why I couldn't do it. Yeah. It's so simple. It's already it's already arc sine, right? So now I want to divide by 8. So now we'll have a 1 minus x over rad 8 quantity squared, and there it is. So just practice.
So the one that I thought we always have to have 1 on the inside. We don't.
No.
I thought it had to be.
Well, yeah. You're talking about this, right? We always want that 1 there, right?
Yeah.
Yeah.
And we got it because this one was and it was 2 instead of 8x or something.
Yeah. So, but I got the 1 here when you were saying this, right? I divided
the ones on the outside of the square. What's being squared even?
Okay, so even if we don't have, hold on. I'll practice on
Well,
complete.
there
Yes.
is a number.
Probably.
It's just,
Yeah. That's what you got to do.
it was the 8.
Instead of saying, well, what if this happened? Go ask Sean. Go ask our textbook. Or go ask Stuart. And start. So you're saying to them, well, give me another problem like that, but take this out. And then you got it. You just start doing problems. Right? You start doing problems. You all can send me work. I'm alone this weekend. My girlfriend just drove to Jersey to help her mom with everything, arrangements. So I'm alone. So you send me problems that you're stuck on via email. I'll answer them. Okay. And of course, we'll meet Monday and Wednesday and test Friday. Right. All right. Have a great day.
Yeah. Before you go back, can you go back to the first problem, please?
Yep.
Let me try and rejoin for a second.
Thank you, Professor.
You got it. Have a great weekend, everybody.
Thank you.
Yeah, the first problem, Professor.
The first problem we did today.
Yes, please.
Yes. Let me just stop my recording real quick.